What's up, guys? Hey Devs here. Okay, we're back with some more Leetcode. I just want to say thank you for all the subscribers. We're currently, last time I checked, and there was at 98. 99? We're one away from 100. That's huge. My video went from like 100 views to 127 views since last time I checked. So day 17 is really popping. I'm guessing it's because it's a shorter video. 9 minutes isn't really popping, so I'm guessing the sweet spot's around 15 to 20 minutes. This be around where this video is. In this video, we picked another easy problem. I know I said probably try to do a harder problem today, but it's the first day with the puppy. The puppy's in the bed with the girlfriend. He is snoozing, so we are letting him sleep. I also took a nap with him. He kept me up last night. I woke up at 3 o'clock to him whining. So I took him out, brought him back in, got him back in bed. Then he woke me up. I got up at 6 to take him back out. So in total, in total, I got probably 6 hours of sleep with waking up or 5 hours of sleep because I woke up at 3 and then I got back to bed around 4. I woke up at 6 and then took him out. So I was tired, dude. And I went to our school therapy today. And if you're in your university and you're struggling with something, I definitely recommend you use your resources. Most schools offer some type of counseling or someone you can talk to. It was very helpful today. I very much enjoyed that. And then, what else is it? Yeah, so we took care of the puppy today. Today was big puppy day. And he's snoozing. I got a YouTube notification, so I checked YouTube. Saw I was at 98 subscribers. I was telling my girlfriend about it, and I was like, "Oh shit, I haven't made a video today." She was like, "You can do it real quick before you go to work, because I got work from 4 to 9:30 tonight, and by the time I get home, I'll be tired. I won't make a video." So we're gonna do an easy problem. Just try to get this out of the way. Tomorrow I'm off, and we might be at 100 subscribers tomorrow. So we're gonna do the 100 subscribers special. And I was thinking about doing one easy, one medium, and then one hard problem. That way it'd be a pretty lengthy video. And I'll probably try to figure them out before I record the video so I can explain pretty well. But we're gonna do a binary search tree problem because I was thinking we could do the add or remove from binary search tomorrow for the medium problem. Where's it at? Yeah. No. Yeah, delete node and BST binary search tree. Um, that takes a little bit of rerouting, and I'm not too familiar with that. But binary search tree will get us used to using binary search trees. And this one is you are given the root of the binary search tree and an integer value. Find the node in the binary search tree that the node's value equals value, and return the subtree rooted with the node. If such node does not exist, return null. So so we want to loop while root does not equal null. And then if root ever reaches null, we know that, or let me read the problem. I'm getting far ahead of myself. So, like I said, yeah, I already read the problem, but we'll look at the examples. So we're given the value 2. The way binary search trees work is at the node you're at, every value less than this node is to the left. Every value greater than the node is to the right. So you can see everything to the left, 1, 2, and 3 is greater than 4. Everything to the right, the 7 is greater than 4, or 1, 2, and 3 is less than 4. And then you can take a look at the 2 node. 2 node also carries the same rule. So 1 is less than 2, and then 3 is less than 2, or 3 is greater than 2. And then this example is the same tree, but whatever. So we want to see if, I'm thinking about just having 3 if statements. So if root dot value, we can check the value if it's in the while loop because it's not equal to null, is equal to value. And then we want to return root, right? And then we want to see if root dot val is greater than the value, then we want to else we want to set root equal to root dot right, and then root dot is equal to root dot left. So given the root 4, it's like we're looking for value 2 in the first example. Okay, and then we'll see if root is not equal to null, then that means we're not at the end of node. So given the end of a node, if we're looking for a value like say 5, 5 will go, okay, 5 is greater than 4, so it's to the right. Okay, we'll see that 4 isn't null. We'll walk through this problem. Let me get the epic pen. Sorry, I did wake up like 5-10 minutes ago, so I'm still kind of out of it. So given the node 4, we see that this node isn't null, and we want to check it against the value 5. And then 5 is greater than 4, so we want to take the right node, because we know if a value is greater than 4, then it would be on the right side of our tree. And then we check 7. So 7 is actually greater than 5, so we want to take its left node. And then this is null. This is actually our root by the time we do 2 iterations of the while loop. And we know if it's null, we break out and we will return the root, which is null as well. That's what it wants us to do. And then, yeah, I think the rest of this should be fine. We can go ahead and walk through the previous problem. So we're looking for 2. We see that 4 isn't null. Then we'll see if the current value we're out is the value. So if this is equal to 2, which it's not, so then we check if the root dot value is greater than value, and it is. So 2 is less than 4. So then since 4, the current value, is greater than the value we're trying to find, it takes the left node, and it sets root equal to this. So root was at 4, and then we're changing it to root to equal this 2, right? And then it doesn't run the else statement and goes back to the while loop. Since 2 is not null, we'll do the first check. So we'll see if this value is equal to 2. And since 2 is equal to 2, we know we found the node we want, and we can go ahead and return that. So I'm pretty sure this solution is fine. Nope. Need your semicolons in Java. Been coding in Ruby and Go all week, so so there we found 2, and then 5 is not on the list, so we return a null value, and this should be a valid solution. Yeah. So I think that's all I'm gonna do for today's video. I gotta start getting ready for work in about 30 minutes. So we'll probably do the delete node problem. We can probably do the find mode in binary search tree. Let's forget subtree sum, bottom left tree value, largest value in each tree road, and absolute difference. What's this one? This is one. Given the root of binary search tree, return the minimum absolute difference between the values of any 2 different nodes. Yeah, that one doesn't look too easy. Binary tree is a tree, that's just a tree. So there might be an equivalent problem. Binary tree paths, k smallest element in a binary tree. This one couldn't be too bad. We might do this for the medium problem, or do the delete element. Count complete nodes. Binary tree path sum. This might be the hard problem. 2, 1, 3 with a path sum of 2, 1, 3. Any empty path is 15, 27. I think this one has to do a little bit with the shortest path algorithm. 9 minus 10. Anyways, we'll look at the hard problems. There might be a balanced binary tree, symmetric same tree, yeah. So this problem is useful for the find the subtree problem that we're just looking at, because we'll have to see if they're the same tree. So we might do this for the easy problem. That way we will be able to do that problem next without any confusion. Yeah, most frequent subtree. Two. Diameter, binary tree tilt, subtree of another tree, yeah. So this one we can get the root, see if it's a subtree, and then we want to check the right and the left side and see if it's a subtree, and then if it's not, we'll want to go ahead and if one of them is the subtree, we want to return true, right? So the way this will work is we'll write a public, I don't know, whatever the other problem returns. But we'll also make a boolean is equal, is tree equal function with the tree node tree 1, then a tree node tree 2. This is kind of the solution I'm thinking. And then we'll go ahead and return, or we'll loop over the tree and we'll see if the root is a subroot, and then we'll go left and right and we'll see if those are a subroot, and then we'll go left and right on those nodes and see if those are a subroot. So keep on doing that until we get false, or there's like some false, or if they're, we can probably check their links. So if they're if one tree is taller than the other, like if it has a greater depth, then we know that they can't be equal, right? So I'm thinking we do that first, and then we can check the values. But we'll figure that out tomorrow. So the easy problem we'll do tomorrow is probably the equal, and we'll probably do the remove or add problem. And then I'll probably try to figure out the hard problems, because I don't think there's too many hard problems in here. Tree cameras. Camera is enough to monitor all nodes if place as shown. Okay. So a camera can I feel like that one's fairly easy. It's just a little algorithm. Cover a tree from pre-order traversal. Maximum sum, binary search tree, and binary tree. Yeah, so there's really not that many hard problems. The only ones I can do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's only 10 binary search tree problems. So we might try to do like an array hard problem. Sudoku solver, first missing, positive. The n queens problem. So someone did suggest this, so we'll go ahead and do this for the hard problem tomorrow. Yeah. So I might look at the solutions tab for this one, because intuitively I can't think. I'll try to think through it at first, and then I'll probably look at the solutions tab and try to understand the solution. Because if you go to the solutions tab and copy and paste it without understanding what you're actually doing, there's no point in even looking at the solution tabs, right? because you're just basically copying and pasting other people's code. If you understand the problem and why they're getting what they're getting, then that's way more beneficial than just submitting code that works, right? That's basically what you're doing with ChatGPT. That whether you know the complexities, the time efficiencies, how to analyze algorithms, stuff like that, and to write your own code. So I think that's where we're going to leave it off for this episode. I think I've been recording almost 20 minutes now, but we've been tired because of the new pup. Tomorrow it's me and the pup at home by ourselves from 12 to 9:30. That's when my girlfriend works. So he'll probably make an appearance in the video. I'm gonna try to keep him in the kennel, especially while I'm on my computer. I'm recording. I'll do the rest of my schoolwork on the couch so he can lay right beside me. But when I'm recording on here, I'll probably keep him in the kennel because we've been trying to kennel train him. And good thing about pups is you want them to be in the kennel whenever you just need them to be in the kennel without whining. So we've been working on that, and just throughout the day we'll put him in there like 5-10 minutes. If he whines, he especially whines when we're not in the room or I'm not paying attention to him. So I'll walk. There's a little, you can't really see this, but I'll walk behind the fridge and he will see that I'm gone. He'll start whining. I'll walk back. I'll be like, no. He'll stop for a second and I'll go back and then he'll start whining and then he'll whine less and less and less. And then about the third or fourth time, he'll stop and he won't do it the rest of the night unless he like there's a problem. He pissed himself and shit himself in there last night. That's one of the reasons he was barking. So I let him out. He also doesn't know what it means to go out. We've been trying to potty train him, and the way you potty train a dog is you say the same thing, like you need to go potty, go potty. That's the word we've been using. Then we take him outside, and then as he's going, we'll be like, go potty. And anytime he does potty outside, we give him a treat and we praise him. We're like, good boy, go potty, good boy. And then we give him a treat, of course. And but it's only the first day. It's a learning process with dogs. But I'm a big dog person, love my animals, and I've been wanting I've had my own puppy before. I had Ella, it was a little golden retriever pup, but she got taken away by the pound because you can't. She ran away. She ran away from our house one day, and if that happens in the city and they're not on a leash, then the pound can pick them up. They've never called the pound on us before, but we had a dog Jackson, another golden retriever. Um, he was part of the same litter, and he got in a car wreck and he had nerve damage in his right paw, so he couldn't use it, so he just had it up here, and so many people thought his paw was broke. He just couldn't feel it, and it would cost like 2-3 grand just to get it cut off for the surgery for that. So we couldn't do that, and we just kind of left it as is. Both of them ran away one day. The pound saw, or someone saw them, thought we were neglecting our dog. In reality, it didn't bother him at all to have his arm dangling. So the pound took him, slapped us with $2,400 in roaming at large fees because they left the house and they were so far away. And then they also tried to get us with like neglect, and said they already did the amputation surgery, and we'd have to pay for that as well. So we'd end up having to pay like $5,000-6,000 just to get our dogs back. So I'm so grateful to have a little puppy. It's a little Labradoodle. I'll probably show him on video tomorrow. But that's gonna be all for today. I gotta start getting ready for work and go love on my girlfriend before she kicks me out of the apartment. Anyways, y'all stay blessed, keep going. Hope you have a nice day, and Hey Devs is out.